Hi everyone, and welcome to this video on reflections. Now, reflections is one of the 4 transformations, and this is probably the easiest one. So what we're going to look at is how we can reflect an object in a vertical, a horizontal, and a slanted mirror line, and how we get this new shape, this image. You can see here the labels, so D, E, and F. We've got D dash, E dash, F dash. We often use the dashes to show the object being reflected. Okay, rather than call it like G, H, and I, for example. And it's because this point F is matching on. So let's have a look what happens. So, when you do your teeth or do your hair in the mirror, whatever, you're used to seeing how a mirror line works. You go close to it, the image that you see is closer. Even if you touch it, you can see your hand, say for example if you touch a mirror, it will be on the mirror. Okay, so as you move further away, so does the image. It's pretty clever really when you think about how a mirror actually works. Now, also, this is when it leaves the world, is what happens if I go past this mirror line? Okay, so wow, did you expect to see that? Hopefully, maybe not. And if I keep going really far past, they just swap positions. Now we're starting on this side, reflecting in the mirror line to get over here. Okay, so it doesn't actually matter which side of the mirror line we are on. Okay, so let's have a closer look at actually what is going on here. So I've taken a few screenshots, and the important thing I want you to realize is if you count the squares, so let's go to the mirror line, 1, 2, 3 squares, you will see that it's 3 squares the other side. That is really, really important. If we do it again here, 1, 2, 3, 4, 5, 6. So on the right hand side, this should also be 6, which it is. Okay, so I'm just going to get rid of those lines quickly. The other important thing I need you to realize is this. Now if I join the corresponding points D to D dash, E to E dash, and F to F dash, what do you notice about these green lines, these horizontal lines, and how they meet the mirror line? They meet at right angles. Okay, that's a really important message. But it's obviously pretty easy, we're just counting squares. Let's have a look at another one. Yeah, exactly the same. So you've got 1, 2, 3, 4, 1, 2, 3, 4. Pretty easy. And again, if I was to join these up, I would get a right angle here. Well, here's a screenshot of when it went over. So what's actually happening? So D is now on the right hand side, but 1 square away. So now D dash is also 1 square on the other side. It's not going to remain on the right hand side of the mirror line. That will never ever happen. It always crosses the mirror line. E is stayed on the left, it's 2 squares away, so E dash is 2 squares away on the right. And F has gone over the mirror line, 2 squares over, so F dash is 2 squares on the other side. So don't be afraid or put off when the shape crosses a mirror line. There's nothing to be worried about. Okay, let's go back to GeoGebra and have a look at the angled lines. Okay, so I didn't mean to have that there. Just tidy this up a bit because something's gone a bit wrong. Okay, so let's start off nice and close to this mirror line. In fact, that's not probably the best position. Let's go even closer. There we go. Right. Now, the angled lines is where it all starts to go a little bit wrong for people. Now, this one should be pretty obvious. You can see that there's this distance is the same. Okay, but it's a bit harder when you're looking at a point much further away from the number line. If I just move this 1 square to the left, you can see now if you look diagonally, you've got 1 square and a bit, or half a square, and that's even harder when you're looking from far away. So counting squares is a little bit different. We're still going to count squares, but we're going to actually change the way it happens. So you can see the further I move it away, it still obeys all the same rules, but it's a little bit harder to see. Touching the mirror line, obviously they're going to share a point, and when we go past, the same thing happens as before. So, I've taken a few screenshots again, so let's have a look at some. Now, just like before, if we join the corresponding points of C to C dash, oops, helps if I don't have a horizontal line. So C to C dash, B to B dash, and A to A dash, you should notice the same thing happens as it did before. They cross at right angles. So how can we make sure that when we're counting the squares, we always create this right angle? Well, what we're going to do is this. So just get rid of all of those lines. So let's look at C to C dash. I'm going to count not diagonally across because that creates problems with half squares. I'm going to count either 2 squares to the right, or I could have gone 2 squares down. So if I've gone 2 squares to the right, I'm going to make sure I go at right angles. If I go up, that obviously makes no sense. I'm still on the same side as the mirror line, so I have to go down. And I get to my new square. If I started by going down, again I've got to go right, because if I went left I'd be on the same side as the mirror line. I would go to create this 90-degree turn. That will guarantee when I join corresponding points, I create that 90-degree angle with the mirror line. Okay, so we count at right angles to make our lives a bit easier. Let's have a look at B. So it's up to you. Do you want to go right or do you want to go down? I don't really want to ever go through a shape, so I'm going to go right. So I've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I'm going to count 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see it's in exactly the right place. Let's have a look at another one. So yeah, this is the one with the 1.5, but you can see it's 3 and 3. Okay, and you can do the same for every single one. That's all you have to do. You go right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and do another 10 squares across 5, 6, 7, 8, 9, 10. And that's it. You count squares. If it's on an angled line, you count at right angles. Now that only works because this is a line going through, bisecting all these little squares. We'll never ever give you a line at a different angle, so this method will always work. And again, when it goes across, let's just look at the C. The C is this side, so it's gone 1, 2, 1, 2. Okay, nothing's changing. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So let's actually do some questions. So this is a classic style of question. We have to reflect the shape in the line y is always minus 1. Well, hopefully you know where that line is first of all. So y is always minus 1 is here. Just going to write that on there. So y is always minus 1. If we look at these coordinates, we've got 1 minus 1, 2 minus 1, 3 minus 1, 4 minus 1. It's always minus 1 in the y. A lot of people draw it a vertical angle, vertical line, but we're going to talk about that in a second. So now we've drawn our mirror line, we just have to reflect it. So we just count the squares. 1, 2, 1, 2. This point, 1, 2, 1, 2. And here it's 1, 2, 3, 4, 1, 2, 3, 4. And then you use your ruler and you join it in. Okay, so they may have called this one shape A. Oops, meant to use a pen for that. So shape A. So we will call this one A dash, or they might say label it shape B, for example. So here's an x equals 1. So where do x coordinates always equal 1? This line here. Let's pop that on. So this is the line x is always 1. 1, 0, 1, 1, 1, 2, 1, 3. The x value is always 1. So now we have to reflect it. So let's count the squares. 1, 1. 2 squares, 2 squares. 3 squares, 3 squares. It is as simple as that. And then we join them up. Oh, I missed that one, but I think you can forgive me. So there we go. So for example, if they might say this is A labeling your reflected image B, you could put a B in there, or A dash. The line y equals x. So y is always x. What I mean is the coordinates are always the same. So 2, 2, 5, 5. The y and the x are always equal. And that line is here. Be careful, if the scale's not the same, you can't just stop at the top right hand corner, but you're just looking at the points 1, 1, 2, 2, 3, 3, 4, 4 and drawing a line. Okay, so let's start counting squares, but this time we're going to count at right angles. I'm going to go left, so then I have to go up. I could have gone up and then left. So that's that point, and I'm going to draw this long straight line. So I'm going to go to this point. So 1, 2, 3, 4, 1, 2, 3, 4. Now what I would say is draw that line in straight away. When you've got the angled lines, let's draw it in. It's easy to go wrong otherwise. So we've gone to here, so let's go to this point now. So let's reflect this one. So I've gone 1, 2, 3, 4, 1, 2, 3, 4. Now that was from there to there, so that's exactly what I'm going to do again. So I'm going to get my straight line and draw it in. So now we're going to go to this point. So this point is 1, 2, 1, 2. We're happy with that on the line, and we join it in. Okay, so it looks like it's been rotated. You could argue that it has, but if we're asking you to reflect it in angled lines, it does look like it's been spun round. The mistake I see most often is people will draw a shape like this, or a bit longer, sorry. They'll draw that shape, they just put it over there. Okay, obviously that is completely and utterly wrong. The main reason is, if you join the corresponding points, they don't cross the mirror line at 90. Last one we're going to look at is the line y is always minus x. So what that means, if we have a 3, the y value is 3, but a minus value. So the y is always the negative version of the x. If we had a minus 2, the negative version of that would be 2. And if you do enough of these points, like for example 5 minus 5, and so let's go minus 4, 4, just swap the signs basically, you end up with a line looking like so. And again, be careful, it's not always the top left to the bottom right. Look at the scale, just plot the coordinates. Now we have this green rectangle. So let's start with this point. We're going 1, 2 to the line, 1, 2, counting at right angles. This one, 1, 2, 3, 4, 1, 2, 3, 4. I'm going to just, this shape is not a very difficult one to draw, so let's just do all of them without thinking too much. So 1, 2, 3, 1, 2, 3. You see I decided to count to the line slightly differently then. That's up to me. And let's do this last one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so then you just join them up. So 1, 2, 3, and 4. Okay, again, the biggest mistake, people get this point here, but they end up drawing something rubbish like this. Okay, we don't want to see that. Okay, that's obviously wrong. So just count at right angles when angled lines. That's it. Right, best of luck.